In this video, I'm going to show you how to solve a system of equations by graphing. And then I'm going to do a second series of videos for this lesson because in school we're also going to do solving by substitution, kind of for the same learning day. So I just want to talk about real quick some things that I have right here. It says, well, first, a system of equations. Let's talk about what it is. It's defined as a set of two or more equations that should have the same variables. So notice how in the two equations that we have here, they both have y's and x's. And the solution to what would be your system of, in our case, linear equations, but there are other equations that may not be straight lines. The intersection would be the point of where those two lines cross. So that's what we're going to look for in this video today, to graph these two lines or these two lines or these two lines and see where those two lines connect, if they connect at all, and then what that point of intersection would be. That is called the solution to the system. So now here's our steps to solve graphically. Number one, graph each equation separately. So graph each line. Number two, find the intersection point of the system, and that's going to be an ordered pair. It's going to be a point labeled x comma y. So I'll actually write that down here for us. So we're going to look for a point where they cross. We're going to find the value of those two numbers, x and y. And then number three, you should always go back and double check your work, plug that number back in and just confirm that it works. So now this is what I'm going to do. I'm going to graph in this first equation here. I'm going to graph x is equal to 4. And when you see x equal to a number, what that really means is that you have a vertical line. Oops, L-I-N-E. Okay, so we had this phrase Hoivux in my class, and I'll explain what that means real quickly here. Hoi stands for horizontal lines have zero slope, and their equation is y equal to a number, versus Vux says vertical lines have undefined slope, and they are x equal to a number. So I see x equal to a number, and that tells me my line is going to go in a vertical fashion, which means up and down. So I'm going to find 4 on my x-axis, and then I'm going to draw a vertical line through that point. We're going to go straight up and straight down. So there's my first equation. So I graphed my first one. Now graph my second one here. I'm going to use a different color just kind of for emphasis. My y equals mx plus b tells me that I'm going to start at a y-intercept of 4 on the y-axis. So that's where we start, a y equals mx plus b on the y-axis. And my slope is negative. And it doesn't say the number here, but what we really have is negative 1x, which means I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. I'm going to go in that pattern. And I'm going to continue going down 1, right 1, and putting a point when I go down 1, right 1, until I see the point where those two lines will cross, and I can actually see what that point is right now. First, let me draw my equation here. All right, so there's y equals negative x plus 4. This one was x equals 4. And now the point where these two lines cross is this point right here. And it crosses at this point on the x-axis, which would be an x value of 4 and a y value of 0. Now what you should always do is confirm. Plug that number back in and check that your solution is indeed what you thought it was. So just, in case you made a graphing mistake. So I'm going to plug in, does 4 for my function here, if I have x equal to 4, does my x value of 4 equal 4? Well, that was an easy one to check. That's true. And now my second equation, y was equal to negative x plus 4. I'm just going to confirm and check. I'm going to plug 0 in for my y. I'm going to plug 4 in for my x. And is this statement true? Negative 4 plus 4 is equal to 0. Yes, that's true. So we've just confirmed that that point is indeed the point of intersection, meaning the solution to our system. All right, let's try two more. Now these two lines are in nice forms, ready to graph, and so I'm going to graph these two here. I'll start with negative 2x minus 4, so my y-intercept is negative 4 on the y-axis, so I'm going to put my point there. And now my slope is negative 2, which means I'm going to go down 2, right 1, down 2, right 1. And I'm going to continue going down 2, right 1 until I get enough points that I feel comfortable putting a line through them. I'm actually even going to continue the process going backwards and just kind of fill my grid. Now I'm sorry the graphs aren't super crystal clear, but I think you can do your best and put your points roughly with a slope of 2 here, -2. This is kind of a grainy graph here. And now the second one here, my second equation, -1 is my y-intercept, so I'm going to start right there. And my slope is -1/2, so I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. It looks like my line is getting further away, so I actually have to work backwards, which would be up 1, left 2. Oh, there we go. Up 1, left 2, up 1, left 2. And get enough points until you feel like you can real nicely connect those points with a straight line. And now what I'm going to do is write down this point up above, and I'm going to confirm my solution here. So this is my solution, and it would be the point -2, 0. And then I'm just going to check that that is my solution by plugging it into my two functions. So my first function was y equals -2x minus 4. I'm going to plug a 0 in for y. I'm going to plug a -2 in for my x here, so -2 there. And let's just confirm. -2 times -2 is +4. 4 minus 4 is 0. Yes, that's true. And then my second equation, y was equal to -1/2 x minus 1. If I plug in a 0 here for my y and a -2 for my x, I'm going to have half of 2 is 1. Negative times negative makes this a +1. Is 1 minus 1 equal to 0? That is also true. So we have confirmed our solution is indeed -2, 0. All right, now one more here. Let me zoom in just a hair for you. Neither of these two equations is in y equals mx plus b form. So you have two choices here. What you see is called standard form, and standard form is when you have your x term in the front, followed by the y term, and equal to your number term alone on the right. Now, standard form is generally used for finding your x and y intercepts. But maybe we want more than those 2 points because, you know, maybe it's not going to intersect on our x and y axis. It happened to in these 2 points, but that doesn't mean it's always going to hit on an x or a y axis. So maybe you want to solve for y, so you can put it in the format maybe, you know, that you're most familiar with, y equals mx plus b, like these were. So you kind of have some choices on how you want to graph. I am going to do y equals mx plus b just so that you see it both ways. But if you did intercepts, if you set 3x equal to 6, your x-intercept would give you 2. If you set y equal to 6, you'd get y equal to 6, which would be your y-intercept. So you could graph those 2 points. I will show you that we will get the same thing regardless, but I'll just kind of emphasize those 2 points, and then I'll show you that we will indeed connect them. So if I solve for y, though, if I have 3x plus y equals 6, and I subtract my 3x to the other side, I have -3x plus 6. So indeed, I've showed that we do start at 6, and my slope is down 3, right 1. So there's just one more point in the middle here that we could use. Down 3, right 1, down 1, 2, 3, right 1. You know, because we don't know where they're going to connect these two lines. Down 1, 2, 3, right 1. Up 1, 2, 3, right 1. Or left 1 in that case, as I went backwards. Okay, so here's my first equation. I'm going to connect all these points that I made with my line. Here we go. Just going to make that as straight as I can. So there's the top equation. Now the bottom equation, again, I'm going to solve for y here by adding x over to the right side. And I'll have the y then equal to a positive x minus 2. And so now I'm going to start at -2 for the second line on the y-axis, and I'm going to have a positive slope because this is a 1x, which means we're going to go up 1, right 1, up 1, right 1, up 1, right 1. We're going to put some points down so that we can connect those with a straight line. And now I can see the solution where the two lines have crossed is at this point, 2, 0. And now what I'm going to do is just confirm, check that that is indeed the solution by plugging it back into my equations. And I'm actually going to use the equations as they began. So if I have 3x plus y equals 6, this would be the same as 3 times 2, the value that I found for x, plus 0, does that equal 6? Well, yeah, 6 plus 0 does equal 6. I've confirmed that that is indeed the solution, but it has to work for both. So there's two equations. I need to check both equations for the system. So negative x plus y, will that equal negative 2 if I substitute in a 2 here? Opposite of 2 plus 0, is that equal negative 2? That's totally true. I have confirmed that that is our solution. So here are the first 3 examples for your notes.